Hi everybody. In this video, I want to continue working with polynomials and I want to discuss how to multiply polynomials. So just remember we're starting with our title up top and then you can always think about adding in your date or the week in which you're working to help you get used to taking your notes and staying organized. And of course, as we go through, just try to follow along and basically write what I write. If you want to write extra stuff, always do that too. So just again, a little reminder that these are still your notes. So if there's something that I say that I didn't write down and you want to add that to the notes, please do. So these are for you as well. And really our goal is to just stay nice and organized so that we can read them and follow along with them later. All right, so for multiplying polynomials, the easiest thing, or maybe the best thing I should say to do, is to really just do a whole bunch of examples. So one thing we want to note here is that when we multiply polynomials, we use that product rule for exponents. Okay? So as a reminder, it says something like if I have a to the m times a to the n, then what I can just do is add my exponents. Okay, so notice here that we have the same base. And if I had the same base, the shortcut then is just going to be to add our exponents. So before I jump in with a couple longer examples, let's just kind of review that. Right, so for instance, if I have something like x squared times x cubed, I have the same base here, they're both x's, so the shortcut says that I can just go ahead and add our exponents, and this becomes x to the fifth. Let's say I have 2x times negative 3x squared. Now, when I have numbers out front, notice that these are different bases, right? That's not the same thing like we had here where they're both x's. Here I have a 2 and a negative 3, and they also don't have any exponents. So when you just have regular numbers being multiplied, you just multiply them like regular numbers. So 2 times negative 3 here is going to be negative 6. Now, if you find it helpful, what you can also do is just kind of write out an intermediary step here and regroup. So I'm doing the numbers because they go together. So 2 times negative 3 is going to be negative 6. And then my x's are the same base. So they are going to go together. So I have x times x squared. And don't forget, if there's no exponent, there is a 1 there. So I have 1 plus 2 here, which is going to give me 3. So my final answer here is negative 6x cubed. And I'm just going to do one more. So let's say I have 2xy times 4x cubed y to the fifth. Again, those numbers out front don't have exponents on them, and they're both different too. 2 and a 4 aren't the same base. So we're just going to multiply those as usual. 2 times 4 is 8. And like I said, if you find it helpful to kind of regroup things, you can do that, but you don't have to. Once you do some practice, I think you'll be able to do most of this in your head. So here, now I'm going to match up the x's. So I have x to the first power times x to the third power. And again, we're going to add those together to get x to the fourth power. And then for my y's, I have y times y to the fifth. And again, that would be a y to the first power. And 1 plus 5 is 6. Okay, so just a little bit of a review on what that product rule is, in case you've forgotten the name. It just means that when we're multiplying the same source of stuff, we can add the exponents. So now we're going to take that to the next step and actually start applying that with the distributive property. And remember, for the distributive property, What we did here is we could take that outside value and multiply it into if we had addition or subtraction. So it'd be A times B and then plus or minus A times C. So we can also take this the next step up. Instead of just multiplying monomials here, so one term times one term, we can actually bring this to the next level and do one term times a binomial. So using two terms on the inside here. So let's do some examples. And again, I think this is a section where I don't know that we need a lot of steps written out, but it's good to do more examples. All right, so let's say I'm going to multiply 2x and then multiplied with, here I'm gonna kick it up a little bit and do a trinomial. So I'm just jumping up one more term here. But it's the same idea, I have parentheses. So what I'm going to do is I'm gonna take whatever is being multiplied and I'm going to distribute it to each of the terms on the inside. Now, to get started, you may want to just actually go ahead and write those steps out here. So I'm going to take the 2x and multiply it by x squared. And then I have the 2x times 4x. Here, if those minus signs throw you off, remember you can always change it to adding a negative if you find that more helpful. So that I'm multiplying the 2x and a negative 1. So whether you change it over and put the negative here, or if you leave the minus sign, it would come straight down here. In either case, you're going to have a negative or a minus somewhere in that last group. And now we can go ahead and we're going to use that product rule we just reviewed to help us finish our multiplication. So here I just have a 2 for my number. So that's just going to be 2. And then I have x to the first power times x squared. So that's x to the third power, right? Because I have 1 plus 2 is 3. Here, 4 times 2 is 8. And then again, each of these x's have a 1 on them, and we add them together. So 1 plus 1 is 2, so I have x squared. And then for this last group, negative 1 times 2 is negative 2 or minus 2, and then I just have the x. Now give it a quick check. These are all unlike terms, so I cannot add or subtract them. So we're going to have to stop. It's good to remember too that it's okay to multiply things that are unlike terms, but we can't add or subtract them. So we have very different rules for multiplication and division as we do for adding and subtracting. And this happens with other things too. So if you think about fractions, we can multiply or divide fractions that do not have the same denominator, but we can't add or subtract them, right? So there's different sets of rules for multiplying and dividing as there typically would be for adding and subtracting. So let's do another one. This time I have a monomial, so a single term, multiplied by a binomial, something with two terms. I'm going to take that negative 4y and I'm going to distribute it into the parentheses here. And if you can do this in your head, that's totally fine. If you find you're making a lot of mistakes though, just write out that next step. So negative 4y times y. And then again, you can either bring that subtraction down and work with the positive 5, or if you find those subtraction signs tricky, just change it over to adding a negative. And we're multiplying negative 4y by negative 5. So either the negative is here on the 5 or it's in the subtraction. It doesn't matter. It'll work itself out either way. Now here on those y's, I would each have an exponent of 1. So I have negative 4 doesn't have anything to work with really. I guess there is a 1 out front, but it's not going to change my multiplication. And then here I would have y squared for 1 plus 1. For the next piece, I have a negative 4 and a negative 5, which is positive 20. And then I just have a y. These are different types of things. So I'm going to stop here. I cannot add or subtract. And I am done. All right, I'm going to do one more here. So I'm going to bring in two variables this time. But it's going to be the same process. I'm going to take that outside term and I'm just going to distribute it throughout. And again, if you can do this in your head, then that is totally fine with me. I'm going to leave the subtraction aside just so you can this time so you can see how it works. So I'm just going to bring that subtraction sign right down. And then I'm going to multiply by the 2xy, and then I'll use the positive 4x squared y. So here I just have a 2 for a number. I don't have any other x's, but I have a y to the first power and a y to the second power. So adding those together, I have y to the third power. Bring down that minus sign. 2 times 4 is 8. Now here I have x to the first power and x squared. So that would be x to the third power. 1 plus 2 is 3. And then here, y to the first and y to the first. 1 plus 1 is 2. So y squared. Now I'm going to check these are different types of variables, right? I mean, I guess they're both the same variable, but to different powers. So they're unlike terms. So we are done. So that's how you can take a single monomial on the outside and multiply it throughout a distribution, whether you have a binomial or a trinomial, like we saw before, or even more terms than that. It still works the same way. We just distribute it right through and use that product rule to add up those exponents. Now, I'm going to kick it up a little bit here, and I want to bring in multiplying binomials. Actually, I'll give this one a little bit of a heading here. So remember that binomials, actually I'm just going to underline this piece too. So binomials are polynomials with two terms. So this right here is a binomial. This right here is a binomial, right? One term, two terms. But instead of just multiplying a monomial on the outside, we're going to actually multiply two binomials together. So how do you do something like that? Okay, so it's going to look something like this. And you can think of it in one of two ways. So the first kind of strategy is to just think about the distributive property. And what you're going to do is you're going to apply the distributive property twice. So you take each of the terms on the outside and multiply it to the next group. So we're doing the same thing here, but instead of just having one term, I have two. So I'm going to do both terms. So let's do that strategy first, and then I'll show you a different strategy if you prefer. And I'm going to try to use two different colors here just so you can see how it works. So I'm going to start with the first term, and I'm going to distribute it to both parts in the next polynomial. So again, I'm going to write this out. It's going to be x times 2x. And then I actually am going to use my adding a negative here. I just think it's going to be a little bit easier where this is more complicated. And then my next group, I'm going to add that to x times -1. And now I'm going to do the 5. So you can put the little things up top if you want. I like to do it on the bottom just so I can see it better. But I'm going to distribute that 5 to both parts as well here. So I'm going to take a positive 5 and multiply it by the 2x. And then I'm going to take a positive 5 and multiply it by that -1. So each piece in the first group gets distributed to each piece in the second group. And then the rest of it is just to simplify. So here I have x to the first and x to the first. So this is going to be 2x squared. Now, this is just -1x. So I'm just going to write it as -x and just clean that up a little bit, or minus x. Here I have a positive 10x, and here 5 times -1 is -5. Now, oftentimes when we are multiplying binomials like this, you do usually have like terms. So notice that I have a -1x and a positive 10x, and these can get added together. So I have 2x squared, -1 plus 10 is positive 9x minus. And just be careful, once you go back to adding or subtracting, remember you don't change the variable. We only add those exponents when we're multiplying. We don't do it when we're adding, and that's another common mistake students make, is they get kind of used to multiplying, and then at the end they'll add and write 9x squared by accident. So just be careful there. Once you switch back to adding or subtracting, we just rewrite the variable as it is. All right, so that's the first strategy, is just to distribute twice. Now, your second strategy is called the FOIL method. And FOIL is an acronym. So F stands for first O stands for outside, or I've heard it also as outer. I stands for inside or inner, and then L stands for last. So I'm going to rewrite the same problem and show you how to use the FOIL method. And you're going to see you actually get the same exact calculations. That's just a different way to think of it. So first means to multiply the first terms together. So I'm going to, again, try to use different colors here. So I'm going to do F in orange. So my first terms in each group. So I'm going to multiply this one to this one. Okay, so notice how it's the first term in each group. So it's going to be x times 2x. And again, I'm going to change over that subtraction to adding a negative. It's just going to be much easier for me to work with. Now, your outer means your outside values. So here's outside and outside. So it's the two outermost values. So you're going to take that x and multiply by that -1. I stands for the inside values, or the two innermost ones. So you're looking at the 5 and the 2x. And L stands for last. So it's the last term in each group. So that 5 and the -1. Now, if you look carefully here, you're going to notice that all I really did was a double distribution, like I just did in the first strategy. But it's just a different way to think of it. So if you find you're making mistakes with the distribution, or you're missing terms, or you're multiplying the wrong ones together, this can kind of help keep you a little bit more organized. So you can do the first ones, then the outer, the inner, and then the last. So here I would still get that 2x squared, adding up my exponents. Here I still have that -1x plus 10x and -5. And when we combine our like terms, just like we did before, you're going to get that 9x in the middle. All right, let's do another example. So we're going to do 4y plus 9 and then times y plus 1. And again, you can use either strategy you want here. So if I want to use the first strategy and just distribute twice, it's going to look like this. So I'm going to start with my first piece here, that 4y. I'm going to distribute it to the second set of parentheses. So it's going to be 4y times y. Now everything is already a plus sign, which is just makes it a little bit easier. So if I have subtraction, I do tend to like to do the adding a negative here, just so I don't lose that negative. But I don't have to worry about that for this one. So I take that 4y and I multiply by both the y and the 1. And then I'm going to take that 9 and I'm going to do the same thing, multiply by the y and the 1. And then I'm just going to go ahead and simplify. So here, let's see, I have y times y. So that's going to be y squared. 1 plus 1 is 2. And then 4 times 1 is 4 with the y. Here I just have a 9y. And then 9 times 1 is 9. And again, a lot of times you do have, not always, but a lot of times you do have some sort of like terms there. So we're going to add those together. I get 13y. And that's it for my like terms. So I am done. Now my second strategy is that FOIL method. And again, I'm just going to rewrite it. All right, so I'm going to use F for my first terms here. So I'm just actually going to write it down here. So there are my first terms. So it's going to be the 4y times the y. And if I simplify this, I get 4y squared. Now I'm going to do the outer terms. So that's the 4y and the 1 going to the outermost area. So 4y and 1. 4 times 1 is 4, so this is just 4y. I'm going to do the inner terms. So 9 and y, which is just 9y. And then in pink, I'm going to do my last terms. So that 9 and the 1, which is just 9. And you can see that we're basically still just doing a distribution here. And then I am going to put it all together. So I have 4y squared plus 4y plus 9y plus 9. I'm going to combine my like terms. And I get the same answer. Okay, so both strategies are good. Doesn't matter to me particularly which one you use. They give you the same answer and even in the same order, just how you want to think about it. So let's do one more. This one's going to look similar, but it's going to look different to start, but it's going to be the same kind of problem. So 2x minus 1 squared. There you go. So here I have a square problem, and I want you to be careful. This is not the same as 2x squared minus 1 squared. That's not the answer, unfortunately. So I can't just distribute that square in when I have pluses or minuses. It doesn't work that way. It only works if I'm doing multiplication or division. So what I have to do is I have to rewrite this. And remember, if you square something, you multiply it twice. So this becomes 2x minus 1 and 2x minus 1. So you can see here, I actually have a double distribution or a FOIL problem. So I'm going to show you that strategy one more time. So I'm going to start with this 2x here, and I'm going to distribute it to both parts. And again, I am going to just change those over so I can make sure I don't lose those negative signs. So I have 2x times 2x, and then 2x times negative 1. So I'm distributing that 2x. And then I'm going to take that negative 1, multiply it by 2x, and take that negative 1 and multiply it by negative 1 again. All right, so here I'm going to have 4. X times x is going to be x squared. There are 1's there. And then I have a negative 2x, another negative 2x, and then here, careful, negative times negative is a positive, so positive 1. Now, when you're squaring, you are going to see a doubling in the middle. So this is not a coincidence. You do see this anytime you square something. So it's kind of a nice check just to make sure you're on the right track, that you do get that doubling in the middle. But again, just be careful. It's only when you square, you don't have to have it in other cases. So if you look back over here, we didn't have that doubling here. We had a 4 and a 9. So it works particularly for squares. If you prefer to think of this as a FOIL, our first terms are going to be the 2x and the 2x. So I kind of tend to like it to write it like this. Just kind of write it more vertically. My outer terms are 2x and negative 1. So again, that's going to be a negative 1 there. My inner terms, again, I have a negative 1 and a 2x. And then my last terms, and then what we just do is we go ahead and we put it all together. Now you can even combine your like terms right away here. Just remember that you're adding. So I have 4x squared, and then it would be negative 2x plus negative 2x. So negative 4x, and then plus 1. So we still get the same answer. Okay. Now I have a couple more I want to do here. I actually want to do one more of this style. I know I said I was done, but we're going to do one more. And it's the same process, but I just kind of like to show you those different answers that we sometimes get. So here's another one. And you may be saying, but we just did this problem, right? It looks almost exactly the same, but it's actually a little bit different. So in the problem I just did, I was squaring, so I had the same exact binomial twice. Here I have the binomial, but it's almost the same. One's a positive, one's a negative. And this is actually a really common style example that we see in algebra. And when you go ahead and you FOIL or you distribute, what ends up happening is your middle terms cancel. So I just want to point out the difference between this and then the squaring one. So I'm just going to do it and just kind of talk it out with you guys and combine both strategies here. So I'm going to start by doing the FOIL, so the first one. So I'm going to start by distributing here. So I have 2x times 2x, doing the first terms, right? And then if I want to do the outer terms, it would be 2x times -1. Next, I would do my inner terms, so the 1 and the 2x. And then I would do my last terms, the 1 and the -1. And now I'm going to multiply it out. So here I have 4x squared. Here I have -2x because 2 times -1 is -2. Here I have positive 2x, and then 1 times -1 is -1. So you can kind of see it's similar to our last example, but not quite exactly the same. And when I go to combine my like terms in the middle, these end up canceling out, right? -2 plus 2 is 0. So I end up with 4x squared minus 1. So again, I just want to throw that example in because we do see this idea a lot of where you have almost the same exact binomial, but the sign in the middle is different. That's the only change. So that's important. It's the only change that occurs. And what happens when that occurs is that you get those middle terms to cancel, which is different than if you're squaring. So just something else to watch out for. Now, the last thing I want to look at here is just some harder examples. So we actually can take this up another level here and just look at a more challenging problem. So when you have more challenging problems, you're just going to extend the distribution idea that we already have and distributing through the parentheses. So let's look at an example or two here. Now, I will say too that I've been doing a lot of integer problems, but you could also apply the same idea if you had fractions here or decimals here. It doesn't change the process. With decimals, obviously, you just want to use a calculator. With fractions, you have a little bit extra work there to making sure you say everything nice and lined up, but the same processes hold. So notice here I have a binomial and a trinomial. So I haven't done anything like this before. But what we're going to do is the same idea of distributing through. And we always take each term in the first polynomial and bring it to the second. You can go the other way. So it's not wrong if you want to go this way, but it just tends to be a little bit more confusing for people. So we're going to stick with like that left to right idea. So I'm going to take that 3a and I'm going to multiply it to each of my 3 parts here. And I'm going to also just change my sign over so I don't forget it. So I have 3a multiplied by a squared. And then I have 3a multiplied by -6a. And then I have 3a multiplied by +3. Now we're not done. We still have to do the 2. So now I take the +2 and I'm going to do the same thing. Distribute this time to all 3 parts. So I have 2 times a squared, 2 times -6a, and then 2 times 3. Now, I will say too, it's nice if you change your signs over, then you can just put all pluses in between because the negative will stay with the number, so you don't have to worry as much there. So that's why I do recommend for more complicated problems using that keep, change idea in your subtraction. And now we're just going to multiply. So here I have a 3. 1 plus 2 is 3, so 3a cubed. Now 3 times -6 is -18, and then a times a is going to be a squared. 3 times 3 is 9, so 9a. Here I just have 2a squared, nothing to really do. Here, -6 times 2 is -12a. And then finally, 2 times 3 is 6. And now I'm going to go ahead and I'm going to combine my like terms. And I'm just actually going to check my notes real quick here because everybody makes mistakes, so I want to make sure I don't make a mistake before I move on. And now we're going to keep going. So if I have like terms, I do see a like term set here and here. And I see another one in here. So that 3a cubed will just come down. I'll do my squares next. So again, we usually like to go in descending powers just to stay organized, but it's not wrong if you write it in a different order. Negative 18 plus 2 is negative 16. So negative 16a squared. 9 plus negative 12 is negative 3. So negative 3 or minus 3a. And bring down that plus 6. Now, for these, you actually can also multiply them vertically. So if you think back to how you multiply whole numbers, and we set it up and we kind of multiply, diagonally, then we add everything up, you can do that here as well. So if you want to try that out, feel free to try it out on your own. I'm not going to teach it that way. I do think it tends to be a little bit confusing. So I'm going to stick with our regular distribution method here, but there are ways that you can multiply vertically. If you're interested, you can reach out and I can point you in the right direction. All right, I'm going to do one more example here for you guys, and then I think that'll be enough for our examples. So we'll do another one of a similar style. There we go. So 5x minus 1 times x squared plus 4x minus 6. So I'm going to start by, again, I have a binomial, a trinomial. So we're just kind of extending those ideas of distributing or FOIL even, just extending it further. So I'm going to start with the 5x and make sure that it gets distributed to every single term in the second polynomial. And I'm also going to change over my signs here because it will just make it easier for me to keep track of that negative. So I have 5x times x squared. Sorry, guys. And then I have 5x times 4x. And then I have 5x times negative 6, or multiplied by. And then I'm going to do that negative 1. So now I have negative 1 times x squared, negative 1 times 4x, and then negative 1 multiplied with negative 6. Here I have 5, and then I have a 1 and a 2, so that gives me x to the third power. 5 times 4 is 20, and again I have x times x, so that's going to be x squared. 5 times negative 6 is negative 30x. Here I just have negative 1x squared. Here I have negative 4x. And then finally I have positive 6. Watch your signs. Negative times negative is a positive there. And now I do need to go in for some like terms. So I see one set here, and I see another set here. So that 5x cubed comes down, and then I see 20x squared and negative 1x squared. So that's going to be positive 19x squared. I see negative 30x and negative 4. So adding those together, I have negative 34x and the plus 6. Now we can take these techniques we already know, we can extend them even further. I could do a trinomial times a trinomial. I could have 4 terms here or 5 terms here, it doesn't matter. So we're just keep extending this distributing idea. The same thing would be true if I wanted to, over here, and I'm not going to do it today, but over here we did a square problem, right? If I want to do a cube problem, I could do the same thing. I would have to write this 3 times, but you have to only multiply 2 things at a time. So once I have this, then I would multiply with my third factor. So we can, again, keep extending these ideas over and over again. But just remember that when we multiply with polynomials like this, just do 2 at a time. Simplify that first, then multiply with any further. So we can keep kind of just building on this same process.